This one is for our friends who are doing SC this term and they have an end term, which I don't have because I already passed last term. So we're just gonna go over this question paper that I probably solved for my end term. Anyway, first question is about this tar command, and it says you are at /var/logs with the following file system structure. Okay, this is the folder and has this current. In this current folder we have 2 logs, and then there's also this backup. We're supposed to compress all files in the folder current into a gunzip compressed tar archive named logs.tar.gz and place it in the folder backup. Which commands achieve this? What are we supposed to do? We have to compress all these files that are in the folder current. Okay, so files in the folder current, which are these 2 log files, into a gunzip, and it says gunzip compressed tar archive. So it's not a normal tar archive, it's like gunzip compressed tar archive named logs.tar.gz. This is the name we're gonna give it, and we need to place it in this folder backup. So how do we achieve that? And there are like different commands, and we have this gzip command, we have tar, and in the tar it's using, all of these are using -czf flags or like options, and here they're writing backup /logs.tar.gz, which is basically probably wrong way. I think we are supposed to write the whatever thing we are compressing. Okay, I don't know, I'm just gonna do ChatGPT, which I already did. And so what happens, yeah, so basically tar command, what does tar command do? So it's used to archive files and directories into a single file and optionally compress them. So it doesn't compress them, it can compress, like we have to, it only, creates an archive. Basically it combines all files into one archive. Okay, it creates a .tar, and so this is basically like we do it in Windows. We compress like a bunch of files and put that in like one zip folder or something, but it is like it's creating a tar archive. And it says, preserves permissions, timestamps, and structure. Compression is usually added with. So how do we actually add compression? We do gzip. Okay, and then it becomes .tar.gz or .tgz. So if we just create an archive, then it's .tar. And if we also add compression, then it becomes .tar.gz extension or .tgz. And then there are like others. So gzip is one, and there are bzip2 and xz. Okay, so yeah, and then what do these options mean for like cvf or this tar command? And so -c just means create archive, and -x means extract archive. So this is for extracting the archive. Okay, C is for creating the archive. -t is list contents. -v is verbose output. So this V is like verbose output, and -f is specify archive file name. Okay, and -z is use gzip compression. So Z means we are using gzip compression. And then we have -j, which means bzip2 compression, and -J, which means use xz compression. And how do we write? Okay, so we write tar, and then we write the options, and then we write the name of the archive. Okay, so whatever name we want to save it as, we write it here, and then we write the file or the folder name. So something like that. This is backup.tar is what I want my archive to be named as, and the things that I want to archive, they are in this folder, something like that. So now we can go, and what do we want to do? We want an archive named this, and we want it inside backup. So it should be here, and it should be like backup slash, the name, so that it's in the right directory backup. And then, then like it's about like how do we actually write the names of the files. Okay, so here is like current slash and then using asterisk. I guess like everything inside current, this is what it like to mean basically everything that is inside, the current. Okay, so yeah, which option is correct? So here, like this one is obviously wrong, okay, because it's putting the archive file inside current folder, which is what we don't want it. Okay, these two are probably, they're writing it in the correct order. And then there's also this gzip-c current. We don't know anything about this gzip command, so we're not gonna look at it. So which one is correct? Okay, and tar-czf. What do these options mean? C means create archive. Z means to do the gzip compression on it. And F, what did F mean? And F meant specify archive file name. Yeah, so both of these, using the same options and they're correct, they would create a gunzip compressed archive. So this is correct, but how do we write, they didn't just write the folder name like they did in this command, they're basically writing either dot, so current dot, and then current slash asterisk. I don't know if the syntax current dot is correct, but they also have this dash C here. We don't know what this dash capital C means. Okay, let's just look. F equal file name, Z equal gzip, V equal verbose. So yeah, these are like easy to remember, I think. So we want how to write this is glob. Yeah, so this is probably a correct syntax, but it doesn't include hidden files. We don't have any hidden files, so it doesn't matter. So this is, okay, this archives the contents of the folder, not the folder itself. What about, dash C folder, and it did something like dot. It means something different from folder asterisk. So this means change into folder archive dot the current directory contents. So this is something different. It means change into folder, and archive dot means the current directory. So basically archive the current directory contents, which is, we don't want that. Okay, so the archive contains the files inside folder without storing folder slash itself as the top level directory. Archive the folder itself. Archive contents when extracted. Archive only contents. If we just want to archive the contents, then these are similar but not identical. Problems, hidden files, and shell expands arguments before tar. Okay, hidden file excluded can fail with too many files. Shell expands, okay. Basically, yeah, so folder dash C folder dot actually also includes hidden files. Okay, so basically they both do the same thing, except that, the first one, this way doesn't actually include the hidden files, but we don't have hidden files, so it doesn't matter. So both of these are correct. And then we have gzip-c current, whatever is inside the current directory, and backup/logs dot, and then it's putting that into this, putting the output of this command into this file. Is this the correct way? Gzip compresses file.txt, replaces it. Okay, so there's also this gzip command, and we want to know what all of these options mean. -d means decompress, -k means keep original file, -r means recursively compress files, -l means list compression info. Okay. Gzip options. We have -c, which means write to std out, means write to standard output. Okay, so there is this gzip-c keeps original automatically. Okay. It does not create a valid tar.gz archive. Okay. Gzip compresses input data into one gzip stream and writes to std out, but gzip fundamentally works on one file at a time or one continuous write stream. It is just compressed raw file contents concatenated together. Why this is best? Suppose a.text equal hello, b.text equal world, then this would do, hello world. File boundaries and names are lost. So it doesn't, basically, it doesn't preserve, all the properties and stuff that this tar thing did. So we have this, something written here. What was written here? Yeah, preserves permissions, timestamp structure, but this one doesn't do all of that. But it does create an archive, right? Okay, so we could do tar, and then we could give it to gzip, and then put it into, sends it to std output. Gzip compresses that tar stream. Anyway, it seems like they are different, so maybe gzip compressed tar archive. Basically, it won't be a tar archive. Here, let's check. Yeah, these two are correct. They are not. So yeah, that was tar and gzip. Now, this is the second question. Inside /home/user, you have a file names.txt with the contents. This is the content. And with the contents, okay. You need to find the sorted list of distinct names, count how many distinct names exist. Okay. Find the sorted list of distinct names. We need a sorted list, but only distinct names. So Alice would come first, once, Bob would come once, Charlie, David. Yeah. So how do we do that? We know about the sort command. And, okay, they're using T. Why am I getting notifications for some reason? Okay, sort. So this is, file names.txt, so it is sorting. So it's this sort names.txt. Okay, we just sort it, and then unique would find, the unique. And for unique to work, like, we always need to sort first, because unique just lists out, basically, if you have like Bob coming twice, like next to each other, they are basically next to each other, then this unique would only include the first one. And yeah, like any other repetition after it, like, it wouldn't include. But if you have like Bob coming here and then Bob coming here, like, unique wouldn't do anything, because like, this Bob is not coming right next to, like another Bob. This Bob is not coming right next to the first one. So unique doesn't work on it. Okay, unique only works when you have consecutive, repeated, items. So that's why we need to sort, because when we sort, then we would have like these repeated words basically coming, next to each other, and that's why unique command would, only find the unique names, unique list of names. Okay, so anyway, I think people who know how unique works would know. So this one is definitely wrong. Like, without sort, this unique wouldn't be able to sort it, because this is not already sorted. So we need to sort first, and then so we just do sort names.txt, and then we put unique command. And okay, so this is done. We found the sorted list of distinct names, but now we need to count how many distinct names exist. How do we count it? So to count it, basically we want both of the output. Okay, we want the sorted list of distinct names, and we also want to print out the count together, I think. So that's why they need the T command, because T command would do basically this, like, it would let it be printed. So it would, whatever is the output till here, this would be printed on the screen, but this output would also go down this place. Okay, like in the next chain of commands. So what is this dev/tty? I think this is maybe this is some kind of file that I am supposed to know about. And wc-l is just a way to count the number of lines. And so we have the sorted list of distinct names, and wc-l would give us the, it would give us the count of, all these items. So it would work. But what is this dev/tty? I don't know. This wouldn't work because it wouldn't do both of those things. Okay, so it would sort, and then it would do unique. Okay, unique-c. So basically it would give the count of unique. Wait, what does unique-c? Yeah, adds a count. Okay, it adds a count before each unique line. So it writes 2 apple, 3 banana, 1 orange. Okay, so it would write the count next to, yeah, so like, this is good. If we do sort and then unique, like, it is doing both of these things. It would list out the distinct names and a sorted list of distinct names, and it would also write the counts. But I don't know if we want it to come together, or yeah, I think like this would work. And then we have, here it says sort -u. What does -u means? Okay, let me just, list out options for both. Options for sort and unique. Okay, so for sort command, -n means numeric sort, -r is reverse, -k is sort by column key, -u is unique lines only. Okay, so -u is unique lines only, but I think like this is the default. You don't have to actually write -u. And oh, okay. So if we do sort -u, then it's gonna only give us the unique lines. Okay, so we don't even need unique after this, if we are doing sort -u. And Okay, so I think this would work because this doesn't need unique, and this would work because we need unique here. So both of these are gonna work. And what is this dash dev dash slash dev slash tty? The current terminal connected to this process. So TTY means teletypewriter. At least it originally meant that. Normally output no longer appears on screen, but echo hello forces output to the terminal. Okay. Read from terminal even in pipeline. But I don't know, like I didn't really see this in SC. Like I know that, like I've seen this, but I don't think that we really spent a lot of time on it. Current terminal, yeah, I know about dev null. No idea what that is. Okay. If we do t slash dev slash, what does it mean? Send a copy of the input to the terminal while also passing it onward. T duplicates stdin, writes it to files and ignore. Oh, okay. Because T actually, it does things like it basically, if whatever the output of this command is before T, then it prints it out on the screen, so it gives standard output, and then you can write the name of the file where you wanna, print it. Sorry, yeah, like if you wanna, it also redirects the output to a file, so it does two things. It prints it out on the screen and it also saves it inside a file. So, we can't just use T to give the output to, the next command. We can't pipe it like this. So that's why I think they use dev slash tty, which is it takes command output and writes a copy directly to terminal, also continue pipeline output normally. So it is also writing it to terminal. Okay, so it's just doing the simple thing that it's just, like taking the output, printing it, and also giving it to, the next command in chain. So this is what it's doing, Okay. Here, stream, terminal, and next command. Okay, so this is what it's doing. So I think like all three of these are correct, but this one isn't because unique doesn't work if the list isn't sorted. And this is wrong. Yeah, we got the answer wrong. So which one is wrong? Which one is wrong? Sort names.txt. I don't know. Maybe this one is not right because it's printing this like together. The number of, it's writing the list of distinct names, but it also writing the count like on the left. So maybe this is not correct. We don't want this output. Yeah, so we didn't want this type of output. So this is kind of tricky, I think. Anyway, we have this now, file users dot, yeah, so we were looking at, the options of sort and of unique command. I think it's good to look at that. So sort dash n is for numeric sort, dash r for reversing order. So if you're sorting, like, it's gonna be sorted in ascending order. But like if you reverse it, I think it's gonna be in descending. And dash k is for, you're sorting by key or column. Unique lines only, dash u. Dash t is for field delimiter. Dash h is for human readable numbers. Dash b is for version sort. Dash f to ignore case. Dash m for month sort. And I don't know what this month sort means. We have unique. Dash c would count the number of duplicates. Oh, so okay. What we wanted in this one is like we wanted to count how many distinct names exist. So like, how many distinct names there are. But unique dash c would count like how many of each name there is. Okay, so like Alice comes 2 times, something like that. So that's why this one is definitely wrong. We want the overall count of, distinct lines basically. Anyway, dash d show duplicates only. Dash u show unique lines only. So dash d would show only the ones that are duplicated. Dash c would print out the count of all the duplicates, and dash u would show unique lines only. Dash I would ignore case. Dash fn skip first n fields. Dash sn skip first n characters, something like that. And sort dash n is for numeric sort, so this works for numbers. Output is 123. Yeah, so if we do just this normal sort, then this is gonna put 20 after 1 and before 3 because it's sorting alphabetically. But if we do dash n, then it's gonna sort the numbers correctly. Okay, dash r would reverse, and dash n is numeric sort. So we can also just combine options like this. Dash k is sort by column. So if I write dash k2, then it's gonna sort by the second column. And then we are also putting dash n, which means like it's sorting numerically. So this is pretty easy. This was in the OPPE, which I failed. I wish I knew about this dash k, so we could sort by the second column easily, and then sort dash t, and then this is to use a delimiter. So dash t comma would tell you like the delimiter is comma, and then we want to sort by the second field, so we put dash k2 and then dash n because we want numeric sort, something like that, and then the file that we want to sort. Then we have sort dash u, unique. So it would print, okay, like it says, it is equivalent to sort and then just using the command unique, but sort dash u just does it together. Sort dash h, so human sizes. So input 2k 1m 500. Sort dash h sizes.txt correctly understands. Okay, so it would sort by these like k, m, etc. probably correctly if we use dash h. I think dash v version sort would sort versions correctly. Okay, unique dash c, now it's unique. So unique dash c, yeah, would also list out the counts of all of these lines. So apple probably came 3 times and banana came 2 times. Unique dash d would show only the duplicates, so it would show lines appearing more than once. Dash u would show lines appearing exactly 1. Oh, so unique only if we do unique dash u, it would show us only the unique lines. So if anything is duplicated, it won't show us that line. Okay, and dash I would ignore case. So if we use dash IA for this list, then it would treat them all the same. So we would only get apple, probably in lowercase. Don't know. Yeah, but this is probably useful. It would have come really helpful in OPP. Anyway, unique dash fn skip fields. So what do we want to do? We want to unique dash f1 files.txt. So f1 skip fields. So we want to skip one field. Ignore first field when comparing. We want to ignore this first field and we want to just find unique from this. Yeah, so this is pretty good. And then skip characters, we can also ignore characters. So dash s2 means ignore first two characters. Very common combinations, we don't need this. Let's forget about this. Yeah, okay. So we've done this. Now let's come to file users.txt contains Alice. Okay, so it contains this. We want to replace every colon x colon with colon admin colon and display results without modifying the file. Which command works? Okay, so we just want to replace this x with admin. So how do we do that? Use sed. So sed s. So sed, and we write inside of this quotation, single quotation, and s. We write s and then search and replace string. So what it's doing, it's writing s and then it's searching for colon x colon in every line, and then it's replacing it by colon admin colon and then slash. So this is how to actually do correct search and replace. We should have 3 slashes, and first field is the one we're searching for, second field is the one we want to replace it with. So this is correct, okay? And then this is the name of the file, so users.txt. So this one is correct. This is the correct field. Sorry, the correct command. Anyway, then we have set dash I. And what does dash I mean? What does it do? Dash I. Okay. I don't know. Is it for like ignoring case? We don't actually need dash I. But let's look at, options for set command. There is dash I. There is dash N. Oh, sorry, dash I, yeah. So dash I is like if we want to make changes in the file itself, So dash I is modifying the file, but we don't want to modify the file. So this command is not correct. Then we have awk, okay. Then we have grep. So grep, what does it do? Grep is, for searching basically, or I don't know what it's called. Global rejects, I don't know. Regular expressions, probably. Anyway, so it's searching for all the lines which contain, this thing, whatever is inside the single quotation, So it's searching for all these lines, and then it's just writing them, all of those lines back into this file. So this is like literally doing, it's doing something completely. It's doing something that we don't actually need to do. So this is incorrect. Now this is the only one that's left, awk. So awk and then dash capital F, then colon. So dash F is used to write, field delimiter. So field delimiter is, colon. So that means we need to basically first field is this, second field is this, third field is this. This is what it's doing. It's telling you, the field delimiter is this colon. Anyway, then inside the single quotation mark and inside this curly braces, we write our, awk command. So in curly braces, it's writing $2 equal admin. So it's searching, basically it's saying, $2 equal admin. Basically $2 make $2, the second field, equal to admin. Okay, so it would basically turn X into admin, it would replace X with admin. This is what it's doing. It's just assigning $2 to the second field to this value. And then, yeah, this is the end of this command, and then it's writing output field separator. So, it would write down all of these fields, and we are just defining what should it separate these fields by. So it should separate by colon. Okay, so we need to specify that. Otherwise, like, I think it just it just writes spaces instead. So it just writes fields and separates them by a space. So we have to write this, and then this is end, and then it does print. Okay, print means basically print out all of the fields. So it's gonna print all of these fields, and then all of these fields, so something like that. But I don't know why this OFS is written in this block. This should have been written in a basically begin block, if you know what I mean. But maybe this is correct too. Usually we would write OFS in the begin block, but I think these are correct. So yeah, these are correct. Then you would need to know how awk works and how set works. Set is pretty easy, especially searching and replacing. Awk, if like the syntax is pretty easy, but you would need to look at it once. All the blocks, begin and end block, all of that. Anyway, let's get to the fourth question, and it's writing is etc password. etc does not exist. Sorry, it's not is, it's ls. Requirement: save only error messages into error.txt, save only successful output into output.txt. So we need to just do redirection here. We want to run this command ls, and then we want to save the error messages into error.txt and output into output.txt. So how do we do that? So we write the command, and to redirect output, standard output means 1, and error is represented by 2. So this is correct. What it's doing is just taking the output and putting it into output.txt, and then it's taking the error and putting it into errors.txt, which is correct. And here what it's doing is like sending, this would send, if we write nothing and we just write this error, then it basically means this one error. Okay, so this means that it is gonna write the output of the command to this file output.txt, but error would come on the screen if we don't do anything else. But it also writes 2 and then this arrow and then $1. Basically it's saying wherever the standard output, meaning 1 is going, you send 2 also. So 2, basically 2, and redirection arrow means redirecting the error. Send the errors to wherever 1 is going, basically the standard output is going. So what it's doing is like sending both the error and the output to this output.txt file, but we don't want that. We want to send errors to this file. Okay, and this one says 2, and redirection arrow means the errors go to errors.txt, and then this single arrow means the standard output into output.txt, and this is correct. This is basically the same thing, just different order. And they didn't put the 1 here, but we don't need to put the 1 here. Okay, the 1 is already assumed, whatever. And then the second one is just incorrect. I think this is just incorrect syntax, and yeah, this is incorrect syntax. So these two are correct. Yes. Then we have question 5, and this is another awk one, and we have end block here. So how do we write blocks in awk? this is curly braces, is one block. So this is one block. This is, one block. And if we write end and then the block, then this means like this is the ending block. And if we have written, begin here, this would be the beginning block, something like that. So there are actually three blocks. We have the begin block. So if we write begin and then a block, that will be the begin block. Then we have, a middle block that runs for every line. And then we have the end block. So what happens is that if we write a begin block, whatever is inside the begin block, that only runs once in the beginning, okay? And then this end block runs at the end only once. But if you write just, blocks without any keyword, without begin or without end, then that block, that runs for every single line, okay? So yeah, this is how awk works. Pretty simple. What does it want us to do? We have the sales.txt file. It has all of these lines, okay? And it doesn't have any, block. Okay, so it does have this block. Okay, this is not begin block. So this block, whatever is inside this block, this is gonna run for every single line once. Okay, so this is what's gonna happen. So it says you must compute total sales per person, sort results by total sales, descending. Which commands achieve this? So we first need to compute total sales per person. So these are probably the sales, and we just need to, okay, so for every person we need to add the sales, and we can do that easily by a, what do you call it, dictionary type thing. I don't know what it's called, but basically we can have a dictionary. So that dictionary would have something like, maybe it's like array, and in that array, the array would be like, so we would have Alice, and then Alice would be the key, and then that key Alice would have some kind of value like 200, something like that. And then comma, then we would have another key, so maybe like Bob, and then that Bob would have a value, something like, 150. So it's like this kind of dictionary, but it's not called dictionary, okay? And then if we do, we can, refer to it by writing array, and then in these brackets we can write the key. So like Alice, so if I write, Alice, which is the key, then like I can, this would basically give me the output, which is, 200, like this. But also if I want to basically assign something, so I wanna, in this array, I want to have a key Alice, and I want that key to have the value, 200, then I can do it, with this statement. So something like that. It's really simple. And let's just delete it. Yeah, so basically array $1 means the field 1. So what is this doing? It is creating an array that like we created, and then it's saying $1, which is the key. So it's saying make the key $1 and then plus equal $2. So what is it doing? It's doing something really simple, which is, can I write something here? Can't write. How to write? Don't know why I can't write. It was working just now. how do we write brush? No, not working. Probably because of okay, now it's working. So what it's doing is just doing, array and whatever is in the field 1. So for the first line, the field is Alice. So it's just doing Alice. Yay! Such a beautiful handwriting. And it's just adding, and we already know what plus equal means. And then it's just adding $2 to it, okay? So it's whatever is already, the value of array Alice, if it actually has a value, it's basically just adding something to it. But right now, this just means, array Alice equal to 100. This is what this statement is. If array Alice was already 200, maybe we were on this line, then it would do, it would add 300 to it. So basically, it's just summing up. It's doing what we want, This is gonna sum up, the values for the same person. So we would, by the end of this command, we would get, this total sales for Alice, for Bob, for Charlie, which is what we want. So yeah, this block is what is gonna get us the total sales for each person. But then how do we actually print it? Because we also need to show the results. We need to sort them by total sales in descending order. So for that we need this, end block. And this end block is it's going in the array, like it's for I in array, print I, comma, array I. So it's basically just doing whatever is in the array, whatever key is in the array. So like Alice is a key, Bob is the key, Charlie is a key. So it's going through them one by one and then printing him out and printing its value out. So it's going to print Alice, 500, Bob, 250, something like that. So this command is good, it's working. And then we need to sort it in descending order. So sort -K2. So K2 just means, the second field. Okay, so by the key 2 or something, we want to sort by the second field. We want to sort by the sales, which is correct. And then it's doing dash, yeah. N means, numeric sort, and reverse means in reverse order because it gives it in ascending order. Okay, so we want descending, so this R is correct. So this one is correct. It is calculating the total sales and then it's printing it out, and then we're giving it to the sort command and sorting it in the right order, because this is correct. Sort -K1 sales.txt. So this is completely incorrect because we are giving it, the first field and sorting it. We're not actually calculating the total sales. So this is just completely wrong. This one, sum $1 plus equal $2, which is exactly the same as this. It's the same thing. And then in the end, basically just the name is changed. Here they named the dictionary array, and here it's sum. Okay, that's it. So it's doing the same thing, but then it's doing sort -RNK2. So is this correct? I don't know. Is this correct? Can we just write all of the fields together like this, -RNK2? No idea. Cat sales.txt, cut -t. This one is also incorrect because we need to first compute the total sales for each person. This is not gonna be able to compute. Okay, so both of these are incorrect, B and D, but C could be correct because they have the right options, but they didn't write the field first. They wrote everything together. I don't know. I think this is correct. Yeah, it is correct. So question 6, make dir -p project 1, 2. So this is gonna expand. So it's just gonna do, it's gonna create project 1 and project 2. So 2 directories, and inside project 1 and project 2, like both of these directories gonna create module 1, module 2, module 3. I think people already would know this if they had studied. Okay, so we have, this make dir -p. This is pretty easy. Okay, so what it's doing, it's gonna, if we write curly braces and, dot dot, like if we have something like dot dot 5, then this is gonna expand to, 1, 2, 3, 4, 5. Like this is an expansion that happens. So make dir is just like we are creating directory. -p is used in this command. So like, okay, let me just show you what this command would do. It's gonna go and be like, project. Wow, writing is really hard. So 1, 2 is gonna expand into 1 and 2. Okay, so project 1, project 2. Okay, so like, we have project 1 and project 2. And then after that, we get project 1. And then this module is also going to expand. So it's going to be like, module 1, 2, 3. So basically, it's going to create a directory, project 1, module 1, 2, module 1. Basically, if we write the directory structure, okay, so we're going to have like 2 project directories. So we are going to have project 1 and we're going to have project 2, and let's take a better color. This is the background. This is okay. Let's take this. So in the project we are going to have module 1 and module 2 and module 3, and they're all directories because we are using the make dir command. And in the project 2 directory, we're going to have module 1, module 2, and module 3. So these are the folders that we're going to create. So, okay, so project 1, 2, and inside each of the project folders that we created, we're going to create these 3 folders, module 1, 2, and 3. Okay, so this is what this command is doing, and this -p is important because if this project 1 and project 2 directories don't already exist, then this -p command would create these. Okay, so like if the parent directory before the slash don't exist, it's gonna create those parent directories. If we didn't use this -p, then this command would give us an error. So that's the problem. That's why we need to use -p. And then, so what it's doing, this is not the full command. It also has an int. So another command which is touch project 1, 2, module 1, 3, okay, /readme.md. So what it's doing, like this is creating all the folders, and then this touch is creating, file, this readme file. So touch is creating readme files in all of these. So like we have project 1, and in that we have like module 1, module 2, module 3, and then we also have project 2, which also has these module directories. So it's this touch command is going in and it's creating these readme.md in all of these folders. So we have these 6 module directories in these. So it's gonna create 6 readmes, like one in each of the module folder. So something like that. Okay, and then there is also this or. So double pipe is or, and it's doing touch fallback.log. Okay, and so here we also need to know what these and what these or do. Okay, anyway, so this make dir -p, this is gonna create directories, and then this touch command would create, readme.md in all of these directories. So the question is, if none of the project asterisk directories exist initially, how many directories will be created by this command? So it's saying like project 1 and 2, these directories didn't exist initially. So how many directories will be created by this command? So we know it's going to create, project 1, project 2, these directories, and inside both of these, it's going to create 3, directories, M1, M2, M3. Okay, so how many directories we have? 1, 2, and then 3. So 1, 2, 5, and then 8. So total, we're gonna have 8 directories. So we're just gonna write 8 directories, which is correct. And yeah, so they only asked one question. Wow. Okay, so what does this and double whatever means? So if we have and, if we have two commands and inside they have this and written, that means like if this command, if the first command succeeds, so if this actually runs without an error, then only we would, run the second command. Okay, so for and, the first command, if it fails, okay, so if this command didn't successfully run, or if this command failed, then the other command, the second command, wouldn't run. Okay, so for and, like the first command has to be true, it has to run without error for the second command to run, otherwise the second command wouldn't run. But if there is an or, what it means is that, okay, like if basically these two commands are, there's and written, so only if these two commands run, like if these two commands are true, then this, because of the or, like this command would not run. Okay, because basically for or, we just need one of the things to be true for the whole thing to be true, something like that. So even if the second is false but one is true, then we get the true result. So if we get first is false, second is true, then we still get true. Only if like we have both false, that we get false. So think of it like this, that basically if this command is true, then the second command, if there is an or, then this second command wouldn't even run. But if this was false, then this would run. Okay, so this is the thing with the and or. So for and, like if this command gave an error, then the second command wouldn't run. Okay, and then think about it, basically this gave a false and this didn't run, so we still get a false. And if this is false, then this command would run. Okay, but if this is true, okay, this is true and this has an and, so this command would also run. Okay, and both are true, then basically this whole thing is true. And if it is true, then this command doesn't have to run. Okay, this wouldn't run. Okay, if this is true, then this wouldn't run. So I think like now you probably get what and or means. Anyway, let's get to the next question. The file /home/user whatever, this contains all of these emails. Which command extracts valid email lines but excludes any that end with .org from the given file? Okay, so we want a command. It extracts valid email lines. So valid email probably means we have at, but excludes any that end with .org. So we just want to remove, these .org lines. Okay, we want to just get, these 3 that doesn't have .org at the end. And it is using egrep. Egrep is just the same, like it is extended regex. So we have egrep, and I hope that people know how basically a regular expression works. So it is doing caret. Caret means the start of the line, and then we have this square bracket, and inside we have capital alphabet, lowercase alphabet, and then numbers, then dot, then underscore, and plus, minus. So basically if we have any of the character one or more times, so we have a plus. Plus means basically we have this bracket. This means, we are describing a character group, and if we're writing plus, it means, whatever character is inside, that character can come one or more times, okay? So it's gonna match any of these characters, so like any number, any letter, underscore, percent, plus and minus, okay? And then at. So basically what are we doing? We are doing we have to be at the start of the line, and after the start of the line, we're gonna match any character that is from this group, and then like it shouldn't be at, it doesn't say at. So basically any character, and then at, and then this does the same thing. It could be any character, number, dot, or hyphen. Okay, so after that is gonna match anything, any of these characters more than one time, one or more, and then it's gonna match the dot, and then it's right, com net. So basically either, after this dot we can have a com or we can have a net, and then there should be like the line should end. So line should start, line should end here, and so basically this is where the line starts, and then we can have any of these characters. So Alice fits it. Okay, so we have all of these characters until at. At is not one of the characters, so it's not gonna match. But then it's gonna match this at, and then after the at, we can have any character, and then, okay, so it also writes dot. What does this dot mean? Okay, does this dot mean, like, yeah, but they're also like escaping this other dot. They're not escaping this dot. Is this okay? Like, can they just leave it like this? This is weird. Why did they not escape this dot? And I don't know, this is weird. But if this dot wasn't here, then it would match anything, any number, letter, or hyphen, until, there would be a dot, and then it wouldn't match, and then, this dot would match, and then we needed com or net. So that would be correct. But it's not. We also have a dot here. Okay, and it is not escaped either. Let's look at the next one. So it's dot asterisk. So this dot means basically it is a placeholder for any character. So we can have any character, and asterisk means 0 or more times. We can have any character 0 or more times, but it has to have, an at here, and then after the at we can have any character 0 or more times, but then we have to have a dot. So basically anything at, anything dot, and then com. Either we have com or we can have net, something like that. So this is what it's saying, and then dollar, like this should be the end of the line. After, basically com or net, there should be nothing else. I hope people know grep already, because otherwise like it is hard to understand. This one is correct, but they didn't write, a caret here. But they don't need to. Like if this is the file, then, this would work. We don't need to specify like, this should be the start of the line anyway. Grab dash V. So dash V means invert match, basically. So whatever lines don't match this, we want those lines. So it's saying that whatever lines has /.org at the end, so whatever line has /.org at the end, don't match those lines, okay? Match all the other lines. So this is correct. We don't want .org at the end. So this is correct, but then it's doing grep at. So it's piping the output and then doing grep at. Okay, so basically we want valid emails. Valid emails are the ones that have at. So it's first removing any of the .org lines, and then it's checking whether all of the lines that we have now, do they all have at? And they all have at. Okay, so this is also correct. It's gonna give only extract valid email. Then we have this egrep, then this is caret. So basically this says, you know, caret inside a character group means, you know, not this character. Okay, match any character except, you know, this one. So we should be at the start of the line, and then we can match any character except, you know, at. Okay, and then so we can match this, and then when this at comes, you know, this is gonna end here, and then we're gonna match an at. Then it says, you know, we can match anything except a space. It's gonna match all of this, and then we should have, you know, slash a dot here, and it says question mark, not org. So okay, basically it's checking. It shouldn't be an org. Then A to Z 2,3. So whatever, like we can have small case letter from A to Z, and they should be either two of the letters, or we should have 3 of them in the end. So I don't know what this question mark this is doing. Basically it could be anything except, you know, org. So after that it could be anything except org, I guess. No, I don't know. This is really confusing. Let's use ChatGPT to explain it. So caret means start of the line. Bracket means character class. Caret at inside class means not at. So caret inside, you know, this character class means not any of these characters. Okay, so something like that. Plus means one or more. So we should have any character except this at one or more times. That's what it means. So one or more characters that are not at. This is the username part. Example, John Alice 123 at literal at symbol. Then we have caret space plus one or more non-space characters. So like Gmail, company.co, escape dot matches literal dot. Anyway, this is a negative look ahead, meaning the next characters must not be org. So domains ending in .org are excluded, and A to Z 2,3 mean lowercase letters only, length 2 or 3. So it is gonna match com, io, uk, edu. Dollar means end of the line, so the whole line must match exactly, something like that. Yeah, so this is just a look ahead. It's saying, basically saying, you know, it shouldn't be not org, you know. So basically after this there shouldn't be any org written, something like that. So this is also correct, but this one is probably not correct because this has a dot, but it doesn't matter. I don't know. Also gonna match a dot. It's gonna match this. Okay, this is wrong. This one is not correct, but these ones are correct. Yeah, are you correct? No, they're not correct. Oh, this one is also wrong. Grab at. I don't know why this one is wrong. Okay, oh yeah, so I guess it is wrong because it doesn't properly validate emails, but I thought we only needed to validate these five. Anyway, I guess we need to make sure that this command works for like all valid emails, not just these 5 lines that are written. Okay, this dot one would work. So this space thing, so basically this is probably like, because this is only gonna work for, you know, the domain names that are only 3 characters or 2 character long. We can have other domain names like, you know, .iitm, .ds, I don't know, .ds, .iitm, .ac, .in, something like that. We also have emails like that, so it's not gonna work for those, but this one is gonna work for them. It's just this also matches dot, so this is gonna work for those ones, basically our emails too. So this one is pretty correct, and this one is also gonna work for all of those emails because it's gonna match any character. These two are like more generally correct. Anyway, move on. Consider the file. This is the file and it has this kind of content. What is the final output after the following command is executed? Grab baz data.txt and then grab xyz data.txt and then or grab bar data.txt. So like this is gonna return true because we have a line that has baz, these letters written. Then, so if this command runs, then because of n, like this command would also run. So grab xyz, but this is gonna be false. Okay, this is not gonna run because we don't have any xyz lines that have xyz written. So this is not gonna find any output. Okay, it's not gonna find anything. So yeah, so because of this, before the or command we get a false because they should have both run because they're separated by an end, but they didn't. So let's say this is now f, so this has to run. So this is gonna run grab bar data.txt. So bar does exist, so this is gonna run successfully, so we're gonna get only bar as a result. Yay, Ron! Come on, this is amazing. Okay, I guess this is not gonna run, and because of that, this is gonna run. Okay, sure, this is great. I guess I misunderstood. I put brackets where they didn't exist. This is gonna be true, and because of this command is gonna run, but it's not gonna give any output. So this command is gonna run because like this wouldn't give any output because this doesn't, I don't know. Come on, let's just in Unix, exit status 0 equals success, non-zero failure for grep. If we found a match, then we would get exit status 0 means true, no match means exit status 1 or false. So end command 2 only if command 1 succeeds. So if command 1 succeeds, then only we're gonna run this. If it doesn't succeed, then we're not gonna run this. Okay. And this one means if this succeeds, then we're not gonna run this because one is enough. Okay, we do the least amount of work. But if this doesn't succeed, then we will run this. Okay, something like that. So we're gonna run this, and this is gonna successfully run, like it's gonna give an output. So we would get a true. This wouldn't give an output, so we would get a false. And because we got a false here before, so we would have to run this. So this would give an output, and that's why we will get baz and okay, yeah, bar, final output baz bar. The shell operators care about command success failure, not printed text. Same thing like I did, but this would still give an output because it succeeded even if like the whole thing is false. Okay, anyway, because the exit status for this command still comes out to be, like non-zero. There are exactly 7 lines in the file with content. So these are the 7 lines. Execute these commands in sequence using VI editor. So we're doing :G fail D. So G means, I think, globally, and we're searching fail. I don't know what G means actually, but anyway, this is usually like these slashes is usually for like searching something. So we're searching lines that have fail written, and then we're gonna delete them because D means delete. Then we have :V. V means visual mode. No, V doesn't mean visual mode because we're writing it after a colon. So V and then OK and S, then dot asterisk and then check. What does that mean? I don't know. V, no idea what V means. And then we're basically searching for OK, and then we're doing search and replace. So lines that have OK in it, then we're finding dot asterisk like anything and then replacing it with check. So basically we are taking the lines that have OK written, so these 2 lines, and then we are basically replacing all of the characters of these lines with check. So OK would become check. And then I don't know what these G and V mean, but I guess we can understand. We're deleting all the fail lines, so fail are deleted. OK have been turned into check. So now we have check, pending, check, done. Okay, these 4 lines, check, pending, check, done, something like that. So what are the final contents of the file? Yeah, wrong. It says OK, check, OK, check. What does V means? What does V mean? Okay, they are often called global commands or pattern-based. So G actually does mean global match. So it's doing pattern commands. So it is deleting all of the lines that have pattern fail because, yeah, that was the... Yeah, anyway, so O, it's inverse global. V is for inverse. Okay. So what are we doing? We're doing the same thing, but like inverse. So we're changing all of the lines that are not okay. We're only taking all of the lines that are not okay. Not okay. So that means all of the lines. S, then dot asterisk, and then check. We're changing them with check. So fail ones are already deleted. We have pending and done. So pending and done are gonna be replaced with check. And so yeah, okay, V means inverse. All right, we got that. Okay, we have these. G means global, V means inverse. G means global, whatever. Okay, doesn't have anything. Yeah, they are not options. Okay, we get that. Okay, they are X commands, which doesn't help. We have GV. Then S is substitute text, just like the Z command. And we can also do G and use this not, which is the same as, V. Or we can do :/pat, which means jump to next match, : ?pat, which is search backward. Then we have W, Q, we already know that. E, file, to open file, read file into buffer, delete lines, yank or copy, put, paste, and move lines. This is for copying lines, and this is for sort. Oh, we can also do sort in Vim. Didn't know that. This is substitute, delete, yank, move. Okay, great, really good. Normal, scripting, edit, automation. I don't know. Yeah, let's check. When testing packet loss using ping-c5 example.com, you got the following output. We only want the percentage. Okay, so we have this and we want to extract this 100% from here. How are we going to do that? So first we are writing ping-c5, like we actually write the command to give this. Okay, then we just want to extract this part. So we're doing grab -e extended. O means just whatever is matching, and we are matching 0 to any number one or more times, then dot, then any number one or more times, %. Great, this is not gonna work probably. If you just match any number, it's gonna match this, it can match this, it can also match this, it can match this, and it can match this. But yeah, it's also finding, I guess. Yeah, so this means we can have any number, and then we can have dot and any number. So we are also getting decimal ones if they exist, ? here. So if the we have a point and then a point and some number after a number, then we are gonna consider it. Otherwise, it doesn't need to exist. Okay, and then we need to match %. Because of this %, it's only gonna match this one. So this is, I think, correct. But it's doing packet loss. They're also writing packet loss. So it's not just gonna give us the percentage, it's gonna give us the whole thing. This is not what we want. I think we just want the okay, this one is good because it doesn't write packet loss, and it's getting the last line. Okay, so we can have many lines here with the same type of output, and we just want the last one. And this is using awk. So they're using awk, and then they are looking for packet loss. This is weird. So they're looking for a line that says packet loss, and then they're getting NF3 number of field. Like the field is 1, 2, 3. Third field. Don't know. This is just a weird command. Why did they write? Okay, print $NF3. NF minus 3. So NF is like total number of fields. So 1, 2, 3, 4, I think. Then minus 3 means, this one. So 1. So they're just printing the first field. This is just wrong, I think. And this one said -n. -n is for like suppressing default output, because by default that would print out all of the lines. We don't want to print out all of the lines, we just want to print out the thing that we want to print out. Okay, so then we have search, and then we're searching for anything, any character, and then yeah, so dot asterisk means any character, any number of times. Then we are looking for 0 to 9 dot, basically any number or dot one or more times that is followed by a percentage. So we want to get a number, either decimal or not a decimal, that has a percentage next to it. So try to find it. Then packet loss. Then it has dot asterisk again. Then it's doing. So we are searching for lines, I guess, that have dot asterisk, like anything, and then percent and packet loss, this type of number, percentage and packet loss written. Okay, and then we're just returning the first field. Sorry, so they used a group, so slash and then this parentheses slash parentheses. So this is a group. They defined a group here, and that group is just the number that has a percentage at the end. So they are basically referring to this. So they are matching any line that has a percentage point and packet loss, so they're matching the whole line, and then they're printing out just this number part with the percentage. Okay, and P means print, so they're just printing one first field. Okay, so \1 means this group that we defined, and P means print. So this one is gonna be correct, and this one is not. Okay, so these two are correct. Then we have you have a file data.txt containing apple, banana, cherry. Run the following command: cat data.txt, out.txt, whatever. Okay. Grep A. So out.txt contains all the lines of data. So basically what it's doing is just doing cat data.txt. Okay, and then so whatever, basically it's just gonna print out, cat just prints out all of these lines inside the file, and so they are not printing it out, they are basically taking its output and writing it to this out.txt file. So this right arrow is redirecting the output of this command to this file, but then it says to arrow and then $1. So to arrow is for error, and so it's saying like any error that comes out of this command. So maybe like this file doesn't exist or something, then we would get an error. So basically redirect the error to wherever the standard output is going. Standard output is going to this file, so it's saying send the error to this file too. Okay, this is what it's doing. And then so we've done all of that. Then we have put this pipe, and then we're doing grep A. But like this command is gonna run, and any output or the error is just gonna go to this file. So there will be nothing, no output that is gonna go here. Like there's nothing to go to the next command. So this is gonna give an error. Okay, grep A, because you're not giving this command any input. Okay, or you're not even giving it a file name. So this is gonna give an error. So both std out and std error of cat are piped into grep A, so only matching lines are shown on the terminal and out.txt is empty. So this is wrong. Only std error of cat is written to out.txt. We know that both are written. Okay, out.txt contains all the lines of data.txt and nothing is printed to the terminal. This is correct, but then we also have this part of the command. The command fails with an error because redirection before a pipe is invalid. This is wrong. I think we can select this. Both std error out and error of cat are piped into grep A, so only matching lines are shown on the terminal out.txt. This is wrong because they are already putting the output and the standard error into this file. Okay, I guess first one is the most correct. Yeah, this is correct. Nothing is going to be printed to the terminal, we already know. Grep A, like, it's gonna fail, but I don't know, they didn't mention it. Okay, now we have script.sh, which has this code, and then we are gonna, from the terminal, run the command ./script.sh 1 2 3 4. Okay, so they wanna, this is gonna be treated as one argument. This is one argument, this is the second argument, this is the third argument, and this command is using $. Yeah. Okay, what is gonna be printed? So inside a file, we can access the arguments that we have given with the script by using, $1 2 3, so $1 for the first argument, $2 for the second, $3 for the third, something like that. But they're not using 1 2 3 here, they're using $* and $at. So $* gives all of the arguments, and $at also give all of the arguments, but they, like, one of them gives them, one argument as like one line, but another one gives, all of the arguments in the same line. So we need to know which one is what. So for arg in $*, do echo arg $arg. So basically we need to know whether this one, like one of them gives the argument, all of the arguments as a list, but the other one would give them as like an array. Okay, and if it's an array, then we're gonna get the output in like different lines, but if it's a list, then we're gonna get in the same line. Sorry, array and list is the same thing, I guess, but yeah, like it's different in this case. Basically, asterisk is like one in, I don't know. Yeah, so we need to know which one is $* is gonna give output like this or the other one. Yeah, so I think asterisk, we know the asterisk stand for everything, so it's probably gonna give everything as 1. So we're just gonna select this. This is not correct. They're not both gonna give the same type of output, and this is completely incorrect because we know the second argument is, whatever is within the parentheses, so like they are both the second argument. So this is wrong. These two are obviously wrong, so this is the only one that is correct. Just remember that asterisk is like everything, okay, but at is like, one at a time, something like that. This one is correct. Then we have this script, and we need to find out what will be the last 2 lines of output printed. So we have this check function, ls non-existent. So it is listing out the contents of this non-existent directory and then sending the output of this ls command, like of this command, to dev null, which means basically it's just sending it into a black hole, and after that it's doing echo done. We know, like it says non-existent. That means this directory probably doesn't exist. So this is going to give an error. But you know, here it only redirected the standard output, not the standard error. So we would still get an error here. Okay. If there is an error for this command, the error is going to be printed out. But if it's not going to give an error, if it actually gives an output, then that output is not going to be printed out because the output is redirected into this file. Okay, and then echo done. So this is a function, and to call a function, we just to write the name. So this is this is calling the function, and then it's calling echo dollar question mark. So dollar question mark just, I think, writes out the exit code of the last command that was run. So we know that this is, if this gives an error, and it probably is going to give an error, then we are gonna get the error printed out. Okay, so yes, ls cannot access non-existent, no such file or directory. Yes, and then this is gonna happen. Yeah, and then you know we are gonna have this command is gonna run echo done, and done is gonna be printed out. And then we are gonna check this, you know, what was the error code of the last command, because the last command is, you know, this command echo done, and this successfully ran. So we are gonna get the exit code of this is like 0, and this is the last command, so this is gonna give 0. So this cannot be true. This can be true, but they didn't write done. Done should also be printed out because this command is gonna run, right? This whole function is gonna run. So these two cannot be true because there should also be written here, like done should also be written here. Okay, so we are gonna have done then 0. Okay, 0 means, you know, like there was no error. Okay, so 0, and this is showing like what will be the last 2 lines of output printed. So first we would have done printed and then 0. Before that, we don't care if it had an error. Even if it had an error or it didn't have an error, we're still gonna have like done and the status code of 0 printed out at the end. So this is correct. Done then 0. Okay, then execute the following script. What will be the output? I'm gonna die solving these questions. Okay, we have this val $echo report.txt. Okay, so dollar and parentheses, this is used to kind of run a command inside. So it's running echo report.txt and then piping the output of this to sed, and sed is doing what? It's searching report and then replacing the report with file. So value is gonna become file.txt. This is gonna give report.txt to here, and then report is gonna be replaced with file. So we're gonna get the value equal file.txt. Then case, so this is a case, switch kind of statement, switch statement. I think people, I don't know, studied this in C++. So it is kind of like an if statement. Anyway, so case $val in f asterisk echo starts with f asterisk dot txt echo ends with. So basically, like, we're just looking at whatever is inside the val variable. So it's checking if $val in f asterisk. So if whatever like value is actually equal to f asterisk. So f asterisk mean like anything starts with f. We already know that this value is going to be file.txt. So it is file.txt. So it does start with f. And so it is going to match f asterisk. So if it matches this, then we echo starts with f. Okay. Yeah, so this is going to be printed out. We're going to have starts with f printed out. Then it has asterisk.txt. Okay, so then, I don't know, like, The Python and in C++ case would only run one of the statements, but I don't know, maybe like, so like if any of the switch case like it ran, so like we ran this one, then the other ones wouldn't run, and only like the last one there was like one case that would run. We could write like that would run in all cases, so even if all the other ran, then it would run, so something like that. But in switch cases, like we only have like one case run, something like that. So maybe if like the first one ran, then we are only gonna have like, I don't know, but it has like 3 lines, so this is default case. Maybe in this one all of them run, I don't know. And we can see like here we have 2 semicolon, here we have 2 semicolon, and here too, but here we only have 1 semicolon for some reason. I don't know the syntax of switch case. But anyway, asterisk.txt is also gonna match because we have that too in because it's file.txt, so this is also gonna match, so it's gonna run this, and then file.asterisk, that is also gonna match, so this is gonna run this, and this is the default case, like this is asterisk means anything, so this is also gonna run. So all of these are gonna run, I guess, but I don't know, it depends on maybe like the syntax of this case. Let's see. Okay, all of these are running. I don't know. Maybe like all of the case, whichever case matches, like we run them no matter what. Anyway, so debug is a user-defined environment variable often used for conditional debugging. $debug is unset before executing the following script: hash exclamation bin bash. Okay, so this is just hash bang. If $debug dash eq1, so this is just if statement. It's asking if $debug, whatever is the value of debug, is it equal to 1? If it's equal to 1, then we print debug mode on. But it says that debug is unset. Okay, so debug is actually, it doesn't have a value. If it doesn't have a value, then $debug is not gonna give any value. I guess it's just gonna be empty, but we have these quotation marks here, so then it's gonna compare, like, I guess it doesn't matter if we're comparing string with this because it treats everything as equal or something. I don't know. It's not gonna print debug mode on because it's not gonna be equal to 1. This could happen. Script exits with error. Script prints nothing can also happen because it's just gonna have a value of nothing, and nothing is not equal to 1. Okay, this, I don't think that happens. Yeah, so script exits with error. Why does it exit with error? Let's see. Okay, so basically it's just gonna be empty because it's unset. Then we would have like a string where, and this dash eq etc, like these only work for integers, so that's why this, I guess this is gonna give an error because it was expecting like a number, an integer here. It's a numeric comparison operator and it expects integer. But then this is an empty string and it's not an integer. So that's why it's gonna give an error. That's what happens. Consider the following cron tab entry. Which of the following statements about this cron tab entry is true? So we have 0, 3, asterisk, 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 and then this. So what does this mean? 0, 3. The script will run at 3 p.m. every day and append output to cleanup.log. 3 a.m. and both standard output and errors will be appended to cleanup.log. And we can see, like, if we have double arrows, so we saw single arrows. If we have double arrows, then it's just gonna append. So like if we have single arrow, then it would just rewrite basically the whole file. And if we don't want to rewrite it, we just want to append whatever the output is, like at the end of the file. We don't want to replace the whole file. Then we use, these double arrows. So what it's doing is, whatever the output of this command is, it's gonna, append it to this file. And then, whatever the error is, it's also gonna append that to, not append, but yeah, because there's only one arrow here. Okay, so this is why, like, it's just gonna write, it's gonna if there is an error, then it's gonna rewrite this whole file with this new error. Okay, so this is gonna happen. Yeah, standard output and errors will be appended. So this is correct, but like they're not both gonna be appended. Errors are gonna be overwrite. So you can see here both standard output and errors will overwrite cleanup.log. So they are not gonna overwrite, and both not gonna overwrite. Like outputs are gonna be appended, but if there's an error, errors are gonna overwrite this file. So which one is correct? The script will run every minute during the 3 a.m. hour. The script will run at 3 p.m. every day and append output to cleanup.log. So 0, 3, what does this mean? 0 means what? 3 means I forgot cron tab. Okay, let's just look at that. Cron tab. Okay, yeah, so we have minute, so 0 to 59 minutes, 0 to 23 hours, so yeah, that meant AM. Then we have day of month, so which day, then month, then week. Okay, so this is 0 minute, 3rd hour, which means 3 a.m. So the script will run every minute during the 3 a.m. hour. Okay, so 0. If we wrote 0, it doesn't mean every minute. If we had it like asterisk, I think then it would mean like every minute. But we wrote 0, so that means it's gonna run at 3 a.m. 0 minute time. Not every minute, but like at 3 a.m. specifically. So every day at 3 a.m. The script will run at 3 a.m. every day, and both. Maybe this is correct. Maybe like because there are, maybe this means like we don't have to write these here twice too. Like this, the errors are also gonna be appended maybe. Let's check. Okay, so yeah, errors are also appended. Yes, appends to file, redirect stdr to the same place as stdl. Okay. Okay, so anyway, this means like it is appended. Error is also appended. Okay, this is great. So this is gonna run at 3 a.m. every day. So not, not every minute at 3 a.m. hour. This is wrong because 0 is written here. If it was asterisk, then I think it would run every minute at 3 a.m. in like the 3 a.m. hour. Anyway, this is a file that has this. Then we have an awk script just doing lines $0 plus plus $0. And for line and lines, if lines line greater than 1, print line lines line. Anyway, so making an array or something like lines. So $0 apple. It's just doing what? Like if we have the same key coming multiple times, then it's gonna increase the count of it. Okay, so when apple comes first, it will give it the value 1. Then apple comes again, then it would increase the value by 1 again. So then apple would become 2. So something like that. So it's basically counting the value of each key. Okay, there's only one field, the 0 means like everything, or the whole line, so all of the fields. But we know that there is only one field, like there's only one word written, so it doesn't matter. Okay, so this is just gonna be apple, then banana, then orange. Anyway, then it's doing in the end block, it's going through each key in this lines dictionary, and then it's checking if if lines line, if lines, apple is greater than 1, if the count, if the value of this key in the dictionary is greater than 1, then we print it. Okay, then print the the lines of the key, and then we print the value of the key. So basically orange is coming only once, so that is not greater than 1. So we are not going to have orange coming in, but we're going to have apple and banana, and they are both coming twice. So that's why we're going to have apple 2, banana 2. That's, yeah, pretty simple. Consider the following set command. Set test. So we're searching for lines. We have this search syntax, // So we're searching for lines that have test written, and then we're doing S means search and replace. So search for fail and replace it with pass, and G means globally. So all the places where we have fail, we're gonna replace it with pass. Only in the files that have test written. Anyway, so replaces fail with pass everywhere in file. Replaces fail with pass only in lines containing test. So this one is correct. If the current user is IATM, current shell is bash, hostname is Linux box, and working directory is this, and the prompt is changed as export ps1 equal \u at \h, then space, then \w, and then $. How the prompt look like? Okay. So, \u means user, a current user, and then \h means the shell, and /w means like the working directory, I guess. I don't know what all of these means, but they are definitely gonna be replaced because we have double quotes. I think double quotes means we're gonna have basically it's gonna replace the variable with their values. So it's gonna be something like IATM at Linux box, and then this, and then dollar. What does dollar mean here? Projects. IATM at projects. Linux box. I don't know. Yeah, this one is correct. Backup files of the home directory are stored with timestamps. To create the backup file, following command was run. Okay, tar, and then czf. C means create. What do you call this? Create compressed. No, not compressed, actually. Create whatever this is. Yeah, archive. Yeah. Okay. Z means gzip. So we are doing gzip compression, and F means in this file, I guess. So backup, and then dollar. So dollar and argument is a way to run some kind of command inside another command. So we have another command that is going to run inside. So we have date plus %y, %m, %d, %h, %m. So date, so this is going to run the date command, and this is how the output of that date command would be printed. Like we would have year, then month, then day, then hour, then minute. So year, month, day, hour. But yeah, so this M means, does it mean this numerical month, or like this month? I don't actually know about that. Then home user, if the command executed on this time, okay, what would the backup file be named? So what would be the name of the backup file? So obviously we would have backup dash, and then 20250921, this .tar.gz. Is this gonna be the output, or is this gonna be the output? Obviously, like, we don't have dashes here, so it's not gonna have dashes. This is correct. Okay, so probably this is the default month. Yeah, numeric. Okay, I think I've done enough.